47 countries lost internet access in just 3 months, and it wasn't hackers or cyber attacks.
Wait, 47 countries? What could possibly cause that scale of disruption? So we're breaking down the cable cuts, the weather events, and the government shutdowns that took down entire nations?
By minute 4, you'll know exactly which regions to avoid for your failover systems. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into cable cuts, storms, and DNS, a look at internet disruptions in Q4 2025.
Stick around to the end for this week's headlines. Let's dive right in.
So let's talk about something that's been keeping me up at night. The absolutely staggering number of internet disruptions we saw in Q4 2025. We're talking cable cuts, DNS failures, storms taking down entire regions. It's like the internet infrastructure decided to show us exactly how fragile it really is.
Yeah, I saw the Cloudflare radar data. Over 180 disruptions just in 2025? That's a lot more than I would have expected.
And here's what really gets me. In Q4 alone, we had submarine cable cuts that took down connectivity for millions of people. Not just slow internet, Alex. Complete blackouts. Imagine running a platform team and suddenly your entire user base in Southeast Asia just disappears.
Wait, submarine cables? I mean, I know they exist, but how vulnerable are we really talking here?
So here's the thing. About 99% of international internet traffic flows through underwater cables. These aren't some thick armored pipes either. We're talking cables about as thick as a garden hose lying on the ocean floor. And in Q4, we saw multiple incidents where ship anchors, fishing nets, even deliberate sabotage took them out.
But surely there's redundancy, right? Multiple paths?
You'd think so, but that's where it gets really interesting. Take the Red Sea incidents we saw in late 2025. When those cables got cut, it wasn't just one country affected, it cascaded across the entire Middle East and parts of Europe. Latency spiked by 400% in some regions. 400%, Alex.
Oh, wow. So this is where platform engineering really comes into play. How do you architect for that level of disruption?
Exactly. And it's not just cables. The Tanzania election shutdown, that was deliberate. The government literally turned off the internet for almost 5 days. Can you imagine? Your entire platform, all your users just gone because of a political decision.
5 days? How does that even work technically?
They didn't completely disconnect from the global internet. That's the fascinating part. The autonomous systems kept announcing their IP space, but they throttled traffic down to about 10% of normal. It's like keeping the lights on, but boarding up all the windows.
So from a platform perspective, your health checks might still pass, but your actual users can't reach you.
Precisely. And that brings us to another huge disruptor, DNS failures. We saw several major DNS providers have issues in Q4 that took down huge swaths of the internet. Not because the servers were down, but because nobody could resolve the addresses.
It's like having a perfectly functioning city, but someone stole all the street signs.
That's a perfect analogy. And then layer on top of that the weather-related outages. Hurricane season was brutal in 2025. We're not just talking about flooding data centers, though that happened too. We're talking about power grids failing, backup generators running out of fuel, entire regions going dark.
This is making me rethink our entire disaster recovery strategy.
Coming up, we'll dig into exactly how some companies managed to stay online through these disruptions. And spoiler alert, it's not just about having backups. We're talking about completely rethinking how we architect for a world where the internet itself can't be trusted to stay up. All right, so let's get into the technical meat of this. When we look at the Q4 disruptions, there are really 3 categories we need to understand as platform engineers. First, physical infrastructure failures, your cable cuts and power outages. Second, logical failures, DNS, BGP hijacking, that sort of thing. And third, deliberate disruptions, government shutdowns and cyber attacks.
Let's start with the physical stuff. How bad were these cable cuts really?
So, in November 2025, we had an incident where 3 major cables in the Mediterranean were damaged simultaneously: the SEA-MEV5, AAE1, and EIG cables. Together, these carry about 80% of internet traffic between Europe and Asia. When they went down, we saw immediate impact.
Wait, 80%? How is that even possible?
Because here's the dirty secret about internet infrastructure. It's incredibly centralized in ways people don't realize. There are only about 550 submarine cables globally, and certain choke points like the Red Sea, the Strait of Malacca, and the English Channel carry massive percentages of global traffic. When Cloudflare radar detected the Mediterranean cuts, they saw traffic from affected regions drop by 65% within minutes.
So what did companies do? How do you route around that?
This is where it gets really interesting. The companies that survived best had what I call geographic traffic shaping built into their platforms. They weren't just failing over to different regions. They were dynamically adjusting their traffic patterns based on real-time latency measurements. One fintech company I know of actually pre-cached critical data in edge locations, specifically because they'd modeled cable cut scenarios.
Pre-cached based on cable cut modeling? That's next level.
Right? They used historical data from previous outages to identify which routes were most vulnerable. When the Mediterranean cables went down, their systems automatically started serving from caches in South Africa and routing through Atlantic cables. Their users saw maybe a 50-millisecond latency increase instead of complete failure.
But that must cost a fortune in redundant infrastructure.
Here's where the math gets interesting, though. That fintech company calculated that every hour of downtime cost them about $2.3 million in lost transactions. The redundant infrastructure? About $500K per year. The ROI calculation basically writes itself.
Okay, but let's talk about the DNS failures. That seems like a different beast entirely.
Oh, DNS failures are insidious because they're often cascading. In December 2025, we saw a major DNS provider have an issue with their Anycast network. What happened was their health checks were too aggressive. They started marking healthy nodes as unhealthy, which increased load on the remaining nodes, which caused those to fail health checks.
Oh no, a cascading failure. Classic.
Within 15 minutes, they'd essentially DOSed themselves. But here's the kicker. Because so many services rely on that one DNS provider, it took down everything from major e-commerce sites to government services. Cloudflare radar showed queries dropping by 90% for about 45 minutes.
So what's the platform engineering lesson there?
Multi-DNS strategies, but implemented correctly. I saw too many companies that thought they were protected because they used multiple DNS providers, but they were using them in a primary-secondary configuration. When the primary failed, the timeout before failing over to secondary was like 30 seconds. In internet time, that's an eternity.
So what's the right approach?
Active DNS with intelligent query distribution. You're constantly measuring response times from different geographic locations and routing queries to the fastest responding provider. Some platforms I've seen are even doing predictive routing. They can detect when a DNS provider is starting to struggle before it actually fails.
That's sophisticated. What about the government shutdowns, though? How do you engineer around a government literally turning off the internet?
This is where it gets philosophically challenging. In Tanzania's case, they didn't cut the cables. They used deep packet inspection to throttle traffic. Some platforms tried to get around it using VPNs and proxy servers, but the government adapted quickly, blocking known VPN protocols.
So is it even possible to engineer around that?
The platforms that maintained some level of service used a technique called protocol obfuscation, basically making their traffic look like something else. One messaging app made their traffic look like online gaming packets. But honestly, this is an arms race you probably can't win. The better approach is business continuity planning that assumes you will lose entire regions.
Which brings us back to that geographic distribution strategy.
Exactly. But before we get into the specific strategies that worked, we need to talk about the monitoring aspect, because here's what shocked me. Most companies didn't even know they were affected by these outages until customers started complaining. Stick around. We'll give you the exact monitoring checklist that could save your platform when the next cable gets cut. All right, so let's get practical. If you're running a platform team right now, what should you actually do with all this information? Because it's one thing to know that cables get cut and DNS fails, it's another to actually prepare for it.
Yeah, I'm already thinking about our runbooks. They definitely don't cover submarine cable cut scenarios.
So first thing, you need what I call an internet weather station. This isn't just monitoring your own services. You need to be plugged into feeds like Cloudflare Radar, BGPmon, and submarine cable status reports. Set up alerts for anomalies in regions where you have users or infrastructure.
But how do you avoid alert fatigue? The internet has hiccups all the time.
Great question. You want to look for specific patterns. A 20% traffic drop in a region, that might be normal. A 60% drop that coincides with BGP route changes, that's a cable cut or major infrastructure failure. One team I work with built a machine learning model that can distinguish between normal volatility and actual infrastructure events with about 94% accuracy.
That's clever. What about the actual platform architecture changes?
So here's my 5-point checklist for internet resilience. First, implement true multi-region active-active deployments, not just disaster recovery sites, actual active regions that can handle full production load. Second, use anycast IPs with intelligent routing. When a region goes down, traffic automatically flows to the next nearest healthy region.
That sounds expensive, though.
It is, but here's how you justify it. Calculate your revenue per minute, then multiply by the average outage duration from these Cloudflare reports. For most platforms, even a few hours of downtime per year more than justifies the infrastructure cost. Plus, you get better performance during normal operations as a bonus.
What's point 3?
Edge caching, but smarter than just CDN. You want to identify your critical user journeys, login, key transactions, essential data, and ensure those can be served entirely from edge locations if needed. One e-commerce platform I know survived the Tanzania shutdown because they'd cached their entire product catalog and checkout flow at edge nodes.
But what about dynamic data, inventory levels, user accounts?
This is where you need to get creative with eventual consistency. They used a technique called optimistic transactions, basically assuming the transaction will succeed and reconciling later. During the outage, they accumulated orders at the edge and synchronized when connectivity restored. They had to handle some overselling situations, but it was better than losing all sales.
That's a big business decision, though, accepting that risk.
Absolutely. Which brings me to point 4. You need clear business continuity priorities. Work with your product team to identify what degraded experiences are acceptable. Can you run read-only for a while? Can you disable certain features to preserve core functionality? Document these decisions before the crisis hits.
And point 5?
DNS diversity with intelligent failover, not just multiple providers, but multiple resolution strategies, local DNS caches, hard-coded IP fallbacks for critical services, even peer-to-peer discovery mechanisms for some applications. One messaging app survived multiple DNS failures because clients could discover servers through a DHT network.
This is making me realize we're thinking about reliability all wrong. It's not just about our services staying up.
Exactly. It's about surviving when the internet itself becomes unreliable. And here's what really excites me about where this is going. We're seeing platforms start to build what I call internet independence, the ability to function even when partially disconnected from the global internet.
How does that even work?
Think about it like this. SpaceX is launching thousands of satellites, creating alternate paths that don't rely on submarine cables. Some platforms are already testing satellite failover for critical traffic. Others are exploring mesh networking for local resilience. The platforms that thrive in the next decade will be the ones that assume the internet will fail and architect accordingly.
It's almost like we're going back to the original vision of the internet, a network that can route around damage.
Precisely, but at a much higher layer of abstraction. We're not just routing packets around damage, we're routing entire user experiences around infrastructure failures. And the tools are getting better. Cloudflare Radar giving us real-time visibility, edge computing providing local resilience, new protocols that handle intermittent connectivity better.
So if I'm a platform engineer listening to this, where do I start?
Start by mapping your dependencies, not just your direct dependencies, but the dependencies of your dependencies. Which DNS providers do your CDNs use? Which submarine cables carry traffic to your user base? What happens if a government decides to throttle traffic? Build that map, then start addressing the single points of failure.
This has been eye-opening. I came in thinking about cable cuts as this abstract problem, but now I see it's something we need to actively plan for.
And here's my final thought. The internet disruptions of Q4 2025 weren't anomalies. They're the new normal. Climate change means more severe weather. Geopolitical tensions mean more cable cuts and government shutdowns. The platforms that survive and thrive will be the ones that accept this reality and engineer for it. The internet isn't getting more stable, but our platforms can become more resilient anyway. Before we wrap up, let's catch up on this week's infrastructure news. The CNCF just dropped their 2025 report, and Forbes is calling it a major turning point for cloud-native technology. According to their analysis, we've essentially hit universal adoption. Cloud-native isn't the new thing anymore. It's just how we build software now.
That's a massive shift in perspective. So if everyone's already using Kubernetes and containers, what's the actual challenge now?
Cultural change and training, apparently. The report highlights that the technical problems are mostly solved, but organizations are struggling with the human side, getting teams aligned, building the right skills, and especially dealing with security in this new paradigm.
Speaking of new paradigms, have you seen Claude? It's this open-source personal AI assistant that runs entirely on your own devices.
Yes! What's fascinating about Claude is it's local first, no cloud dependencies. You can integrate it with messaging platforms, but all the processing happens on your hardware. Perfect for teams worried about data sovereignty.
Though I wonder about the resource requirements. Running AI models locally isn't exactly lightweight.
True, but that brings us to Aspire 13.1. Microsoft's Polyglot platform just got some interesting updates. Info2 reports they've added MCP integration and significantly improved the CLI experience.
MCP integration, that's Model Context Protocol, right? Seems like everyone's trying to make AI development more accessible.
Exactly. They've also refined the dashboard and made Azure deployment smoother. It's all about developer productivity, making these complex systems easier to work with.
And speaking of Azure, Red Hat just announced REHL is now available on AWS's European Sovereign Cloud. That's huge for European organizations dealing with data residency requirements.
Especially in regulated sectors like healthcare and finance. Red Hat's blog emphasizes this gives European companies a trusted foundation for sovereign cloud deployments while maintaining compliance.
Finally, Docker's showing how to run Claude code locally using their model runner. This is Anthropic's agentic coding tool, but now you can keep everything on premises.
Docker blog has a complete walkthrough. It's surprisingly straightforward. Configure Claude code to use Docker Model Runner, and you've got a powerful AI coding assistant without sending your code to external servers.
That's becoming a real theme. Local AI, sovereign clouds, on-premises solutions. Privacy and control are clearly top priorities now.
That wraps up this week's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides.
Until next time.